Hi guys, how are you? Here is a very interesting question. The major product formed in the following reaction. So this is a ketone. Here two hydroxyl group is there. So in presence of alcohol, what will produce with reaction with ketone? So as we know that ketone reacts with alcohol 2 moles to produce the ketal. So this is a ketal. Now when this will react, these two will react with this keto group to produce a ketal, but that ketal will be produced here. This ketal will be produced, and this compound is called a spiro compound. So this is called as spiroketal. Now we have to determine which spiroketal is more stable between these four. This can be explained with the help of anomeric effect. So what is anomeric effect? Anomeric effect was observed in sugar chemistry. As we know that glucose, D-glucose, it will exist in water in two forms, that is alpha D-glucose and beta D-glucose. We'll draw the two form. This is called methyl alpha D glucopyranoside. This ring is called pyran ring. This ring is called pyran ring. So this is a pyranoside derivative of glucose. And the another form, that is beta D glucopyranoside. Sorry, this is beta and this is alpha. If the OMe is remain axial, then it is called alpha. That is methyl alpha D glucopyranoside. Now between these two, this is more stable than this. In generally, in a cyclohexane derivative, a group, let's say R, this is preferentially remain in equatorial position. This is more stable than this. But in case of pyranose derivative, if an electron withdrawing group is remain attached to this pyranose ring, then this will preferentially occupy the axial position than equatorial position. This is called the anomeric effect. Why anomeric effect? Because this is called, these two are mutually anomer, and this effect was first observed in glucose. So this is called the anomeric effect. This is the cause of this anomeric effect. If we draw, sorry, this is the axial isomer and this is equatorial. Now why this is observed? The axial isomer is more stable. Why this is more stable? Because here it is said that this lone pair and this pi star sigma star antibonding orbital which remain vacant, so these two are mutually parallel, and it here a no bond resonance will occur, that is hyperconjugation will occur. Hyperconjugation will occur. And it will get stabilized. One of the reason is this, but here as we see that this is the positive antibonding and this lone pair are mutually perpendicular, so this effect will not operate here. So that is the one reason, that's why the axial isomer is more stable. And there is also another reason. Another reason is here the dipole moment will operate in this direction and here it will operate in this direction. So these two dipole moment are operating mutually opposite direction, whereas in this case the dipole moment will operate in this direction, whereas here also the dipole moment will occur in this direction. So between these two are mutually parallel and there will be a repulsion between these two dipoles, so this isomer is quite unstable. That's why the axial preference of OMe group is observed. And this anomeric effect is observed with any electronegative group like OMe, fluorine, OH, OSE, and the percentage of axial isomer will vary. The percentage of axial isomer will vary with this substituent. One effect is observed here. If we increase the polarity of the solvent, then the percentage of this isomer will increase. Why this will occur? Because if we increase the polarity of the solvent, then the dipole-dipole repulsion will decrease and the equatorial isomer will become more stable. And that's why the percentage of this isomer will increase. And this is a proof that here a dipole-dipole repulsion exists. Now we will compare the four isomer where the anomeric effect will observed. Now as we see here that this is a pyranose ring and this is a pyranose ring. Here this OMe O alkyl group, that is the electronegative group, is attached axially and the antibonding orbital are parallel to each other. So here the hyperconjugation will occur, as well as for another ring. If we rotate this is also in axial conformation and the positive antibonding is in this direction and the lone pair is in this direction. So here also the anomeric effect will observe. If we rotate this direction, then we can see here that this lone pair will come into resonance with this positive antibonding orbital. So in this compound, both these two rings are mutually axial. The OMe group are mutually axial. That's why two anomeric effect will observed here. On the other hand, in this ring, this electronegative group are attached axially. So here this is axially. So here the anomeric effect will be observed, but in this direction it will give. But in case of this ring, this is in equatorial position. So here the antibonding orbital is there and the lone pair is in this direction. So here the anomeric effect will not observe. So here only one anomeric effect will observe. One anomeric effect. Here two anomeric effect. In case of this compound, here it is in equatorial position. So here anomeric effect will not be observed for this oxygen, and in this case here also the electronegative group are equatorial, so it will not observe, no anomeric effect will observed here. so no anomeric effect. And in this case, as we see here, that this cyclohexane, if we see this cyclohexane, then this is in equatorial position, so here we will not observe. And if we consider this cyclohexane ring, then this is also in equatorial position, so here also anomeric effect will not observed, so no anomeric effect. Now we can see that between these four compounds, here two anomeric effect observed, and due to this two anomeric effect, this compound is more stable and it will form preferentially. So our answer is 1. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get such interesting videos, subscribe my channel. Thank you. Have a good day.